We're going to look at some of our vocabulary in the statistics unit. These will be statistical measures, and we'll talk about how these apply to things like measure of center, measure of variability, and also some of the notation we use with this. So first of all, the mode is a very familiar one. It's the number listed the most. If you have a list of numbers, and this is a measure of center. It's not a measure we use very often, but it can be used, and you should be able to find the number that's listed the most. Median is the number in the middle of the list. So you need to list them in order first of all. Now, if this is when there's an odd number, you find a number in the middle. If there are two numbers in the middle, because there's an even number in the list, then you average the middle two. This is also a measure of center. This is a measure that is used quite a bit more often in the work that we do. Now, the mean is a very familiar one. It's the average. When you average something, you add all the numbers in the list and divide by the number of numbers there are. So if there's 10 numbers on the list, you divide by 10. This is also a measure of center. Now, let's talk about the word resistant. Resistant is a statistical measure a statistical measure is resistant if it's not affected by extreme values. So if we were to take and replace one of the values in the list by something that we might consider an outlier or extremely at one end or the other of the list, if this measure that we're taking is not affected by that, then it's called resistant. So an example would be as if somebody very tall were to replace somebody that's right in the middle of the list, then the median would not change. So the median is resistant. To an extreme value, or two extreme values. Now that's because it's right in the middle of values. It doesn't matter what the values are at the end, whereas the mean, it takes the value into consideration, so it is not resistant to extreme values. Now, those are the measures of center and talking about resistant. Let's talk about a couple words that we'll be using. Population and sample, parameter and statistic. Just so you're aware, population and parameter go together, sample and statistic go together. It's kind of convenient because of the first letters. We're talking about a population. It's every individual in the group. Now, if we're talking about a group of people, that population would be as if you put everybody and find the information about them. So the population is everyone. You could define what that big group is. And then if you decide to start taking smaller subgroups of it, that's called a sample. A smaller subgroup of a population. So if we're choosing people out of the population, it's very evident, obvious that we're taking and choosing people. You call that a sample. Now, a parameter is a number that describes a characteristic of a population. So as an example, a population may be all the students at a certain school. Now that population might be a sample in a different context. If I was talking about all schools across the United States and I chose certain schools to be where I use those as a sample, that's a different problem. If I just refer to all the students at a school, that's my population. If I'm finding their average height, that's my parameter. That's a number that describes the height of that population. Now, I might not be able to find out the height of everybody to find out the average height. So if I pick a smaller group of 10 students here, 10 students there, 10 students here, that's called a sample. And if I find their average height, that's called a statistic. So a statistic is a number that describes a characteristic of a sample. This is a good way to predict what the parameter is by finding a sample, getting a statistic, and that will predict the parameter of the entire population if you sample well. So an estimate or a prediction of that parameter, we use a statistic for that. Now, let's talk about some other measures that we use. A standard deviation is the typical distance of values from the mean. Typical distance that values are from the mean. Now, if we're doing a sample standard deviation, this is what we'll use at the beginning here. A sample standard deviation has a very specific formula that will be part of a description elsewhere, but for now, here just as a point of information, the formula is listed as S sub x when we do the sample standard deviation. And you're going to take the square root of the sum of the differences. X sub I is a value of, like if we're taking height of students, it's a specific individual's height. Subtract the mean, add all of those up. When you square it, squaring it will make them positive, and then divide that by n minus 1. Now, where that formula comes from and how it's used will be in a different discussion, but just so you know, standard deviation is a measure of variability. Now, range is another way to measure variability. It's the distance between the min and the max. So all you do to do this is you take the max and subtract the min. Max minus min. This is also a measure of variability. Interquartile range is something that applies, usually we use it as a measure when we're doing box plots. So this is the distance between the first quartile and the third quartile. So that would be Q3 minus Q1. This is also a measure of variability. Shows how much variability there is in the data set. So we locate the data set with the measure of center, and we show how much it varies by using a measure of variability. Lastly, when we talk about a 5-number summary, that's usually with our box plot. We list the min, quartile 1, the median, quartile 3, and the max. That will give us the 3-number summary, or the 5-number summary for a data set. All right, now let's just briefly talk about some of the notation we use for for mean and standard deviation. Remember, this is for statistic and parameter. If we know the entire population and can find the parameter for the mean, we use the Greek letter mu. So that's what represents the mean for that. And for standard deviation, we use the Greek letter sigma, lowercase for both of these. And those would say we've got all of the information from the entire population, we find the mean and standard deviation. But if instead we're using a sample and we find the mean of that sample to get the statistic, we list that as x bar. So when we put a x with a little segment over the top, that's called x bar. That's the mean of the mean using a sample. If we do the standard deviation using a sample, we put a capital S with a sub x on it, S sub x for it. So we've got a lot of vocabulary we're using. The focus here was on statistical measures. We talked about measure center, measure variability, and then what we do with samples and populations, and how we list some of the notation for these, and also how we use those.